Okay, so here is a video that I promised on solution stoichiometry, and it's in two parts. First, we'll talk about the concept and the problem worked out in the book, and then I'm going to ask you to actually do a problem on your own, and then the next video in the series will be working through that video, or excuse me, through that additional problem. Okay, so on page 145 is Solution Stoichiometry, and I'd mentioned in class that instead of going from grams of A to moles of A, we're taking a volume of A, but because we also have a concentration, we can use that volume and that concentration to get to moles in the middle. And so then in the middle here, between moles of A to moles of B, we use our stoichiometric coefficients, just like we do in any stoichiometry problem, to get to moles of another thing in the reaction. Generically, we're saying B, but it's just any other thing in the reaction mixture. And then we use the concentration of B to determine how much volume of B will be produced or used, depending on whether it's a reactant or a product. All right, so let's scroll down here and look at the example 4.8. And so we're given volume of KCl, and, excuse me, we're asked to solve for volume of KCl. And here is its concentration. And we're saying that it will react with this volume of this molarity of lead nitrate. And then we're given a balanced equation. And as mentioned in class, I will always give you a balanced equation if it's stoichiometry. You are required to know how to balance equations, but that'll be a question on the exam that specifically refers to balancing. If it's stoichiometry, the balanced equation will be provided. So, he does a great job at breaking down the problem, but because I'm real big into conversion factors and canceling units out, I think the whole kit and caboodle, the whole process is shown exceptionally well with his solutions box. I guess I'll scroll back up so you can see the rest of it while I talk, but I really want you to focus on this part down here titled Solutions, because it really does focus on the crossing out. We got our little blue lines where here we use the concentration in moles per liter. Again, not big M, because big M, we don't see the units, right? This is moles per liter is symbolized with a big M. But if we were to use a big M here, we wouldn't see the moles per liter, and then liters wouldn't cancel out. So we get liters to cancel out. If we stopped right here, we would have how many moles of lead nitrate were used. But we don't want to stop right here. We use the stoichiometric coefficients to see if this many moles, the solution to this step, react in that balanced equation, then 2 moles of potassium chloride are made for every 1 mole of nitrate, lead nitrate. And so if we stopped right here, we would know moles of KCl, but still not what we're asked for. We're given a concentration of KCl, but see, notice here, the real concentration is moles per liter, but because we're focusing, I like to focus on conversion factors, or this is why I like to focus on conversion factors, we're actually using the inverse of the concentration, because now we need moles of KCl to cancel out, and we need volume to be left, and so it goes on top. And so the solution is 0.35 liters of KCl. So what I want to emphasize is that we're getting moles in the middle, and this step here, the coefficients, is the same regardless of how you get to moles in the middle. Lots of ways to get to moles in the middle. In this case, we're doing it starting with a volume and a concentration. Okay, I'm going to end the video here, and what I want you to do is work on this first practice problem, and then the next video will show the solution to this video, or to this question. Okay, thank you.